Okay, another brief video on how we use pivot tables in the Excel template to make a summary of all the data. And you can Google that as well. So pivot tables are widely used in Excel, so there are loads of YouTube videos and other tutorials and stuff in the web around if you search for that or use just the Excel help. But just a little demonstration for how we use it in our context. Okay, so we again have our Excel template here, which I would like to explain a little bit more in detail. So the bases are the data of each individual participant. So the output file, if you remember, is just a plain text file of presentation, which looks like this. So we have starting with the hash mark, our commentaries, and then we have this header which tells the name for each column, and with a tab there are columns separated by a tabulator, and because the different width as a plain text file, it doesn't look very nice, but it's easy to import into Excel. So if we import such a file into Excel, then it basically looks like this. So this is the same as the text file we've just seen, but now the columns are properly among each other. See the other Excel files for how to import that. And the idea of these result files is that each trial the participant did is a single line. And for each trial we save the following data. The subject, I will increase that so that is a bit easier to read. The subject ID, the group gender age, and so forth. And these data we copy over. Let's just move to the analysis file and then we can do it here. So for each participant with the subject ID, that's what you enter in the beginning. The group code, again, you enter that yourself, the gender and age. Then we have a variable which is called practice, which is 1 if the participant did the practice trials, and is 0 if they don't do the practice. And here practice block is just in which block they are in their practice. So they do several blocks there. Then block task. This variable is very important for us. It tells which condition is the participant doing. It's not filled in for the practice, but for the real task. So when practice is 0. A means auditory visual, auditory single task, so tone only. V is the number only task, visual task. VA0 is the dual task, first visual then auditory task, SOA 0, and AV0, and so forth. VA0, AV0. So you have that. Then we have, again relevant only for the main experiment, not the practice, the absolute trial count. So it just counts the trials as participants do them until in the current version they do 420 trials, and then you see the next participant is coming up. Then we have another trial count here, which is for counting within each block. So you see that after 35 trials, each block is 35 trials. A new condition starts now. We have done the number task, and now we have the visual task. And you can see we have the next variable is the block count. It goes from 1 to 2, so the second block then starts again, and so forth. Block 3 now again starts at 1, while the absolute trial count continues to go on. So we have explained the next one as well. It just counts the block, and there should be 12 blocks in total. So see the other documents for more explanation here. Trial start time and trial end time is just from the time you start presentation, the time in milliseconds when the trial started and the trial ended, and then trial duration is just end time minus start time. You don't have to care about this. This is just for myself for double checking and things like that. Order change, again, not relevant for the current experiments. previous task not relevant, current task is basically the same as the block task, CTI not relevant. Here auditory target, you see what they have been presented, high pitch tone or low pitch tone in the auditory task, and the visual target is just not relevant in an auditory task only, but it's just still set. So we have this, and always both are randomly set, but maybe only one is used. The SOA, this is a relevant variable potentially, and if we have a dual task with a long SOA, the lagged condition, you can see that VA1000 here, then the SOA is 1000, and here the visual target is presented as well. Now here we have what is relevant for us again, the response 1, so which button did they press? This is defined in presentation, what 2 and 1 means. If you go to in presentation to settings and responses, you will see a list of the keys set, and this is the first key as it is defined, so usually it's the key Z or X, and the 2 is then X or C depending on the exact mapping, and whether there was an error in the first response. Response 1 error strict, you can ignore again, and then the response time for the first task in milliseconds. Then response 2, in the single task we don't have anything here, so we can ignore that. If we go down to a dual task, we then have again a button here, response 2, so this is then the visual task first, so this is 1 or 2, and then this one is 3 or 4, and then the RT2, response time to the second task. Reversal error means whether participants pressed the keys in the wrong order, and here pure reversal error means that they pressed the correct keys to each task, but just the order is wrong, while here there may be an error in the key press as well. But what is really important to you is this column, total error, which becomes 1 as soon as they did any kind of mistake, and otherwise stays 0, so we use that. And then response string here is just a mere recording of the buttons they pressed. Again, you don't need that. And then we have the dummy here. What is important in pivot tables is that each column you want to use in a pivot table has a unique heading, so you can't leave them empty and you can't use the same name twice. Now what we have here in this orange shaded areas are basically calculated values. Sometimes the group codes are not done ideally, or the subject ID is not presented just as a number, and then we can just recalculate them to use them in the pivot table. And we also have to do a little correction to the response time of the second task. This is just the way the program is, the presentation program saves the response times. You don't have to care about all these things. Okay, so if we want to include or create a pivot table, we basically select the whole area and all columns we want to use, and so we go down, and you can use much more empty space as well. If you define that already as your pivot table, you can later on add data and it will automatically update. If you do the pivot table only for your current data, you will have to extend that. Then you press insert and go to pivot table. And then it asks again what range it should take, and for demonstration we now start it as a new worksheet. Okay, so this is our pivot table here, and if you click on this you get this pivot table field list. And here what you now have in this field list are exactly those columns with the header we have in the datasheet. So if you look here, RT2 corrected, subject ID 2, group 2, the separator, subject ID. This is, when we go here, exactly what we have here. RT2 corrected, subject ID 2, group. So these columns are now presented here as variables. And this is the pivot table, and we can just drag and drop stuff. And pivot tables, you can also call them contingency tables. So we would like to have our data split by the block task, because that encodes the different conditions, and we want to have different columns for that. So when we do that, then we see that we have these different values, and we don't need all of them. So we can go to this little thing here and just block task, we don't need Q target. The blank we don't need. So these are just the 6 conditions we want to have. Now what we want to have is basically now that we want to have the data for each of these conditions for each participant. So what we can do now is we take the subject ID and say, okay, it should be split by rows. And now we suddenly get such a table, rows by columns. Now in here, these are what in pivot terms are the values. And in our experimental psychology terms, this is the dependent variable which goes in here. And we could, for instance, take RT1, the response time to the first task. So you just take that and drag and drop that here. Now per default, Excel uses the count function. So it tells you that every participant has, for every condition, 140 trials. And this way it's easy, for instance, to spot if a participant has missing data and did the experiment until the very end, or things like that. Okay, this, by the way, should be 70 in the end, and we will see that change. Okay, this is just for demonstration. Now what we want to do is not the count, we want to have the average response times. So we can go here and say value field settings, and then we can do the average of RT1. And now we have the average response times for each participant for each condition. And that's exactly what we need for data analysis. We want to know, participant 1, what was their average response time in the auditory single task, so the tone-only task, what's their average response time in the visual single task, and so forth. Now, why is it called pivot table? Because by rearranging these things, you can just pivot the table around. So for instance, you can do something like this, call the block task here, and now it's for condition A, you have participant 1 to 18, for condition A V0, you have participant 1 to 18, and you can drag this here, and now you have this presentation. So you kind of pivoted the table around. So it's an ideal tool to play around with data and analyze data if you have large sets which can be organized so nicely in columns. So we go back and to that representation, because that's the best way how to do that. Now what we still have here is that it's all data irrespective of whether the trial was correct or not, but usually we want to exclude error trials. So what we can do is use such a filter variable, and that means when we use the variable total error here, that we can say, okay, if you remember, the total error was 0 if the trial was correct and 1 if they made a mistake. Currently we look at all trials, and now we can say, okay, only those where total error is 0 we should look at. And you see that the data are updated. And if we now switch not to the average but to the count again, you will see that it's now not 140 anymore. Another way of changing that is you do a right click in the pivot table and do summarize values by not average but count. And now you see that it's not 140 anymore because it's only the correct trials. And if we switch that to 1, we see the number of errors they made. Okay, so this changes to 0, so the count of correct trials, and we now want to have that by the average again. Okay, so what we now want to do as well is to be able to say, okay, we have two different groups. What are the response times for one group and the other group? So we use this variable group2 as another filter. And now we can select, okay, I only want to look at the BA group, for instance. Sorry, there was a mistake in importing. It should be the FA group. And we get these participants which are just for the FA group. Here it's a little bit in both groups, FA and OM, participants have been numbered from 1 onwards, so the numbers don't change here. But if I change the group label, you see that this changes now. And you can also see that if we again look at the count, we now have around 70, and this is what we should have. So if the participant did everything right in the current version, sorry, you want to see all, then you should have 70 trials per condition. And this holds for the OM group as well as for the FA group. Okay, so only error-free trials. That's basically the trick of that, the average. I can show you one more thing, and this is how to analyze the errors. This is slightly more complicated to understand, but what we now take as the dependent variable, the values, is not the average of response time 1, but instead of total error. If you remember, and now you see the reason for that, if the trial is correct, it's 0. If it's incorrect, it's 1. So let's do the average again. What that means is, if participants have 0 errors, it will say 0 in these cells. And if they made all trials wrong, it will say 1. So we have, if they made half of the trials wrong, it will be 0.5. So what we have here are relative error frequencies, which can be transformed very easily into percentages just by multiplying with 100. So this data point means 0.1 is 10% error rate. What you also can do is simply select this, and in Excel press here on the percent style, and then you get it as percentage. If you want to have more decimal places, you can use this one and reduce them by this. And now you have represented the same numbers as percent. If you want to go back, I think you have to just use the number, the comma style, and then you're back to this representation. Okay, and to the percent. That's the way how the error analysis are done. Okay, that's it.